Hi, I'm Carpenter, a professor of civil engineering here at Lawrence Technological University. Today I'm here to talk to you about water movement in soil. One of the issues with increased urbanization is an increase in stormwater runoff. Stormwater runoff causes water quality problems in our urbanized systems along with increased flooding events. Urbanization changes a site's hydrology. When you have natural ground cover, you have significant amounts of infiltration, both shallow and deep infiltration. When you convert that to an urban system, instead of having 50 or 60% of that water infiltrate into the ground, only maybe 10% infiltrates, with a lot of surface water runoff that's causing the water quality problems we see around the world. So what does this have to do with water movement in soil? Well, with water movement in soil, what we're looking at is three things. We're looking at rainfall, land use cover, and soil type. Rainfall we can't control. Land use cover is part of urban planning decisions. So the last part of the equation is the soil. When you're talking about soil, you have two different primary actions associated with water movement in soil. First is capillary action. Capillary action is when you have individual water movement particles in all directions. This is what happens in unsaturated soils. When you have saturated soils or wet soils, the dominant driving factor is gravity. And gravity is what moves that water down through the soil structure. The other thing that affects water movement in soil is particle size. There are three basic particle sizes. You have sand, silt, and clay, with clay particles being the smallest. So when you have sandy soils, you have open macropores. And open macropores really receive that water well, and the water will move quicker through those macropores. When you get into silty soils, water moves down through there a little bit slower. It has a little bit more of a path to flow through. Finally, when you get down to clay systems, you have micropores. And with micropores, that water is much, much slower. You don't have anywhere near the rate of flow as you do in sandy soils. In addition to soil type, you also have to look at soil structure. With soil structure, you can have granular soils, similar to the sandy soils, which have water will move through them quicker. You can have platy soils, or soils that have a little bit flatter layers, that have a little bit more tortuous path. And finally, prismatic soils. In prismatic soils, the water will actually take kind of a jagged effect through that. So soil particle size and soil structure both influence infiltration rate, and both have a significant effect on how water moves through soil. So generally speaking, yes, we have three different soil types and three different soil structures. However, when you really look at soil profiles, what you'll find in nature is not a homogeneous soil mix. It's actually going to be very heterogeneous, and you're going to have a variety of layers of soil. Some of those layers are going to be clay, some are going to be more sandy. Some of them are going to be more ready to receive water, both in horizontal and vertical directions, than other layers. So it's this complicated soil profile that really influences how water moves through the soil. So the EGRP is an innovative drainage technology. It's made out of polyethylene. It's about 1.25 inches in diameter, and has 4 crescent shapes around a central core. The EGRP works by facilitating water movement between the individual soil layers. This allows water to move both vertically and horizontally between the devices. So during natural rain events, what you'll see is surface ponding, and then the water slowly will infiltrate down through the soil structure, filling in that void space. The red circle on the side represents soil moisture content. In areas of high saturation, you're going to get a lot of water molecules relative to the amount of soil particles. So the EGRP system works with natural forces to facilitate the movement of water from areas of high moisture content to low moisture content. I hope you found this video useful and learned more about water movement in soil. Thank you for your time.